हेलो माय डियर मैकेनिकल इंजीनियर्स, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? प्लीज गाइस डू ज्वाइन मी फास्ट और मुझे जल्दी से बताइए कमेंट सेक्शन के थ्रू, क्या मेरी आवाज क्लियर है? एम आई प्रॉपरली ऑडिबल एंड विजिबल टू ऑल ऑफ यू? So welcome guys to this mini mock test where we will be discussing some wonderful hand-picked questions from the thermal engineering as well as the fluid mechanics. Alright, so please get yourself ready with your pen, paper and calculator. So before I start, let me quickly introduce myself for those who are attending this session for the very first time. काफी लोग already मुझे जानते होंगे. But for those who are here for the first time, this is my quick introduction. I am mechanical engineering graduate from IIT Delhi. Also cleared engineering services examination, worked in SAIL for a couple of years and from last 11 plus years I have been into teaching. So मेरे पास around 25 questions हैं. Let us see how many of them we will be able to solve in the next 45 to 50 minutes. अगर आपने अभी तक मेरे टेलीग्राम चैनल को ज्वाइन नहीं किया है तो इट इज वेरी वेरी इंपॉर्टेंट फॉर ऑल ऑफ यू टू बी पार्ट ऑफ दिस टेलीग्राम चैनल वेयर सो मेनी स्टूडेंट्स आर ऑलरेडी देयर who are preparing for various competitive examination, and this telegram channel is the one stop solution for all your preparation related queries, your doubts, your class notes, PDFs, everything will be shared through the telegram channel only. All right, shall we start? Please make some noise. Do mark your presence in the comment section if my audio video are clear and if you are ready to explore this mock test. And after this session, please go through your performance and try to find out the areas where you are not very much comfortable with. Tomorrow at 7:30 p.m. there will be a workshop, free workshop, which is taken by Dheeraj sir, where he will be guiding you how to clear the GATE 2025 in your first attempt. जी हाँ, if you are thinking that GATE preparation requires a lot of time or in one attempt we cannot prepare for the examination, then Dheeraj sir will be give you some important points which will help you to clear the examination with the best possible score in one attempt only. The link to register yourself is already there in the description box, and if you are planning to join a course which is well organized, which will help you to improve your understanding, which will help you to improve your preparation and your performance in the GATE examination, we are going to conduct a scholarship test. Yes, the scholarship test will help you to get 90% of the scholarship in our various paid courses. So do not miss this chance. The scholarship test will be on 10th of March between 9 a.m. to 9 p.m. and the syllabus is quite same as your GATE syllabus. It is mathematics, aptitude, etc. All right, and again the link to register yourself is already there in the description box. All right, so let us start with question number 1 and 2, which is linked. Okay, so read the question very carefully, find out the important data, parameters which are given, and try to solve for the unknown with your correct approach. Chaliye, let us start together. Steam is to be condensed in the condenser of a steam power plant. It is a condenser. Okay, and the steam is entering, और क्या निकलेगा? स्टीम इधर से डाला, इधर से वाटर निकल गया, because it is getting condensed. At the temperature of 60 degrees Celsius, the condensation of the steam into water is taking place at a temperature of 60 degrees Celsius with cooling water from a lake. Where the cooling water, कौन condense कर रहा है? Cooling water from the lake entering at 15 degrees Celsius. This is at 15 degrees Celsius at the rate of 140 kg per second. Okay, and leaves at 25 degrees Celsius. ये डायग्राम है. There are two fluids, स्टीम जो कि वाटर में कन्वर्ट हो रहा है, वाटर दैट इज यूज्ड, द वाटर फ्रॉम द लेक इज यूज्ड फॉर ट्रांसफरिंग द for getting the heat after the condensation of steam into water. ठीक है? Assume the condenser is perfectly insulated. It means there is no heat loss to the surrounding. Latent heat of the water at 60 degrees Celsius is also given to 2357.7 kilojoule per kg. The rate of condensation of the steam, mass flow rate of the steam which is getting condensed is. कैसे सॉल्व करेंगे? क्या हम ये बोल सकते हैं कि जितना हीट कंडेंसेशन से प्राप्त हुआ, स्टीम के कंडेंसेशन से प्राप्त हुआ, उतना का उतना हीट वाटर ने बॉयल होने के लिए कितने से कितने टेम्परेचर, 15 डिग्री सेल्सियस से 25 डिग्री सेल्सियस तक बॉयल होने में यूटिलाइज किया. That is called as energy equation, or we can call it as first law of thermodynamics. If we write energy equation or first law of thermodynamics, what is that? Energy released. कौन रिलीज करेगा? Steam is getting condensed. Energy released by the steam is equal to energy utilized by lake water. Yes or no? लेक वाटर, राइट? कितना एनर्जी रिलीज हुआ? मास फ्लो रेट ऑफ द स्टीम विच इज अननोन इनटू लेटेंट हीट ऑफ द स्टीम. लेटेंट हीट, द हीट विच इज रिक्वायर्ड फॉर द फेज चेंज पर यूनिट मास फ्लो रेट इज इक्वल टू मास फ्लो रेट ऑफ वाटर, स्पेसिफिक हीट ऑफ वाटर इनटू डेल्टा टी, टेम्परेचर डिफरेंस फॉर द वाटर. मास फ्लो रेट ऑफ द स्टीम अगर चाहिए तो what is the mass flow rate of water? What is the mass flow rate of water? 140 kilogram per second. 140 into specific heat of water. Specific heat 4.18 होता है. Temperature difference 25 minus 15 divide by latent heat. क्योंकि 4.18 किलोजूल में लिया हुआ है तो किलोजूल पर केजी latent heat already given है 2357.7. 2357.7. Your answer will be in kilogram per second. कर सकते हैं? Definitely कर सकते हैं. Quickly find out करिए what is the final answer. 140 into 4.18 into 25 minus 15 that is 10 and divide by 2357.7 is equal to 2.482 kg per second, isn't it? 2.486 kg per second. Yes or no? That is the first part of the question. Simple था. Energy conservation equation, first law of thermodynamics if we apply to the system which is the condenser. Now what is the second part of the question? Says what is the rate of energy destruction in the condenser? How much will be the destruction of the energy? Or because the heat transfer is an irreversible process, because it is an irreversible process, that is why there is some energy dissipation or energy destruction. That is what is irreversibility of the system. We need to find out irreversibility of the system. Can we say irreversibility is T naught, that is the ambient temperature, into delta S for the universe, and universe is the condenser because there is no heat loss to the surrounding. But condenser में भी दो fluids है. There are two fluids. So what is delta S for the universe? That is delta S for the steam which is getting condensed plus delta S for the lake water, isn't it? Steam का क्योंकि phase change हो रहा है. What is delta S for the steam? Phase change के लिए how to calculate? Because there the heat is released, so entropy will decrease minus mass flow rate of steam into latent heat of steam divided by temperature of the steam. So what is the mass flow rate of the steam? Find out कर लिया हमने already. 2.482 into latent heat already पता है. What is the latent heat? 2357.7. 2357.7, 57.7 kilojoule per kg, and the temperature of the steam is 60 plus 273. So delta S for the steam will come out to be negative value. Can you solve it? Into 2357.7 divide by 60 plus 273. What is the answer? 17.57. Please give me yes. 17.57 kilowatt. Are you getting this? Minus of 17.57 kilowatt. Yes or no? And how to find out delta S for the lake water? Lake water is getting the heat and the temperature changes. So we can say mass of water into specific heat of water into natural log of final temperature by initial temperature. Mass of water is given as, mass of water कितना है? 140, 4.18. Natural log of final temperature कितना है? 25. So it will be 25 plus 273 upon 15 plus 273. इसको सॉल्व करिए और मुझे बताइए व्हाट इज डेल्टा एस फॉर द लेक वाटर. What is delta S for the lake water? Can you do it? 25 plus 273 divide by 15 plus 273. 283 and 5, 288, and then natural log of this multiplied by 140 into 4.18. That will give you in kilowatt 19.97. Are you getting 19.97? So that is plus of 19.97 kilowatt. Is it kilowatt? क्या आएगा? ये आएगा मास फ्लो रेट kg per second into kilojoule per kg. Yes, kilojoule per kg Kelvin. So ये आएगा kilowatt per Kelvin. The values will be kilowatt per Kelvin. And then we can say irreversibility is equal to T naught into delta S of the entire system. T naught कितना है? The ambient temperature. What is the ambient temperature? The lake, from the lake, the fluid is entering at 15 degrees Celsius. So ambient temperature is 15 degrees Celsius plus 273 into the, it will be minus 17.57 minus 17.57 plus 19.97 will give you the answer in kilowatt. Minus 17.57 multiplied by 15 plus 273, that is 288. Your answer will be 6. Are you getting 692.53? Kilowatt. That is the irreversibility. Are you getting this? 692.53. Something around 690 will be the correct answer. Hello Muttu, welcome. Welcome to the session. The next question, question number 3 on the screen. A heat engine E1 operates between an infinite reservoir at 800 degrees Celsius and a body B. There is a heat engine E1 which is acting between a source which is at 800 degrees Celsius and there is a sink which is B which is maintained at 550 degrees Celsius, right? The heat is transferred to the engine is 900 kilojoule. Heat is transferred to the engine E1, that is 900 kilojoule and the work output is 200 kilojoule. So easily हम बता सकते हैं what is the heat rejected. The heat rejected by the engine E1 to the sink is equal to 700 kilojoule, isn't it? Now another engine E2 operates between the body B and the atmosphere at 27 degrees Celsius. The heat is rejected to the atmosphere is 350. This is 350 kilojoule. The thermal efficiency of the engine E2 is. So we can find out the thermal efficiency. ये 700 kilojoule है, तो this will also be 700 kilojoule. And what is the amount of work produced? 350 kilojoule, isn't it? If you apply first law of thermodynamics, then energy in will be equal to energy out. So what is the thermal efficiency of engine E2? That is equal to work output upon heat supplied. Work output is 350 divided by heat supplied is 700. 350 by 700, that is 0.5 or 50% must be the answer for question number 3. 50% should be the correct answer, right? अगला क्वेश्चन देखिए, the next one, question number 4. Read the question. कई बार क्वेश्चन थोड़ा लेंथी हो सकता है, but if you will read it properly, if you will understand the question properly, then you will not find any difficulty in the calculation also. Air, the specific heat, this R, gas constant, specific gas constant is 287, specific heat at constant pressure is 1005, and gamma, that is adiabatic index or specific heat ratio, is 1.4. flows sequentially through a compressor. पहले compressor से pass करेगा, then the heater, okay, and a turbine shown in the figure. Finally, it is passing through the turbine which is shown in the figure. Volume flow rate of air coming out from the compressor is 2.33 meter cube per second. That is volume flow rate, V dot. And the pressure and temperature are 276 kilopascal and the temperature is 43. These are the parameters at the exit of the compressor. Air is then heated at the same pressure. Pressure is constant, pressure is still 276 and the air is heated in a heater. The final temperature is 430 and from the heater the air flows through a turbine which produces 1860 kilowatt of power. The turbine is a power producing device, so the power produced is 1860 kilowatt, and heat loss from the turbine, there is a heat loss also from the turbine, that is equal to 90 kilowatt. What will be the air temperature at the exit of the turbine? What will be the temperature at the, अगर inlet of the turbine को हम 0.1 बोल दें और exit of the turbine को 0.2 बोल दें, the question is to find out the value of T2. The question is about finding out the value of T2. The value of T2 to be calculated. So turbine के लिए, turbine is our steady flow device, all right? This is our steady flow device. उसके लिए अगर steady flow energy equation apply करें, Q is equal to delta H plus W, or we can say Q is equal to, what is Q? There is a heat loss, so it is negative minus 90 kilowatt, or we can say Q dot, इसको लिखा जा सकता है Q dot is equal to delta H dot plus W dot, because the values are given in kilowatt. So what is Q dot? That is minus 90. Heat is rejected by the turbine. There is a heat loss. So Q is negative, is equal to delta H M dot into H2 minus H1, isn't it? M dot into H2 minus H1 plus W dot. What is the work produced? Work produced by the turbine is positive. So work produced by the turbine is positive. What is the amount of work produced? कितना वर्क प्रोड्यूस है? It is shown as 1860 kilowatt. 1860, and the air can be treated as an ideal gas. So this will be M dot Cp T1 minus T2. T2 find out करना है ना? M dot Cp into T2 minus T1 should be equal to minus 90 minus 1860. Isn't it? 1950 minus 1950. Now what is the mass flow rate of air? How to calculate the mass flow rate of air? That is pressure into volume per unit time into R into T. PV by RT from the ideal gas equation. So the mass flow rate of air can be calculated as, what is the pressure? Pressure is 276 kilopascal. 276 into volume per unit time is 2.33. R is 287 joule. 0.287 into temperature is 43. What is 273 plus 43? What is the mass flow rate of air? If you can find out the mass flow rate of air, then you can put the values and you get the answer. 276 into 2.33 divided by 0.287 into 273 plus 43. बताइए क्या आएगा आंसर? Are you getting 7.09 kg per second? Mass flow rate of air. Are you getting 7.09? Mass flow rate of air will be 7.09. All right. अब और क्या चाहिए? We do not know T1 also. We don't know T1. So how to get T1? T1 is known, na? Yes. So put the values. The mass flow rate is 7.09 into the kilowatt में है ना? So into specific heat 4.18. Sorry, 1005. It will be 1.005 into T2 is unknown. Minus how much is T1? 430. 430 plus 273. 430 plus 273. 703 is equal to minus 1950. Can you solve for T2? Can you guys solve for T2? और इसको क्योंकि टेम्परेचर है, टेम्परेचर डिग्री सेल्सियस में, योर ऑप्शंस आर इन डिग्री सेल्सियस, सो रेदर देन कन्वर्टिंग इनटू केल्विन यू शुड पुट द वैल्यू इन डिग्री सेल्सियस ओनली. 430. ये सॉल्व कर लीजिए. 1950 डिवाइड बाई 7.09 डिवाइड बाई 1.005. minus 430. Your answer will be 156.33. T2 will come out to be 156.33 degrees Celsius. Yes or no? The value of T2 will be 156.4. A will be the answer for this one. Question number 5. In an air standard diesel cycle, क्या होती है diesel cycle? In diesel cycle, the heat addition is constant pressure, heat rejection is constant volume. Diesel cycle is a combination of constant pressure and constant volume processes. 1 to 2 isentropic होता है, 2 to 3 constant pressure heat addition होता है, then 3 to 4 isentropic expansion, and 4 to 1 is constant volume heat rejection. This is QRE, that is constant volume. 1, 2, 3, 4. ये heat addition, ये heat rejection, and this is how the diesel cycle is done. Compression ratio is 14. What is compression ratio? R, that is volume before compression upon volume after compression. V1 by V2. At the beginning of the compression of air, that is the beginning of the compression of air, 0.1. R, gas constant, Cp, gamma, everything is given. The temperature is 21 degrees Celsius. T1 is given as 21. T1 is 27 degrees Celsius and the pressure is 1 bar. T1 is given as 1 bar. If the specific volume after heat addition is 2 times, specific volume after heat addition, that is 3, V3 is equal to 2 times of V2. Specific volume after compression, heat added in kilojoule per kg of air, mass is equal to 1 kg of air at constant pressure is Qs will be how much? Qs. From the steady flow energy equation, we can say heat added is equal to m into m dot into or m into H3 minus H2, isn't it? Because there is no work transfer. So heat is added is equal to m. M is equal to 1. So Qs is equal to Cp, it is constant pressure process, into T3 minus T2 will give you the answer. Cp into T3 minus T2 will give you the answer. Cp already हमारे पास है. Our objective is to find out T2 and T3. T3 और T2. So 2 to 3 जो process है, that is constant pressure. So we can say volume is directly proportional to temperature. So V3 by V2 is equal to T3 by T2 is equal to V3 by V2 is 2. So T3 is equal to twice T2. So our expression for Qs is equal to Cp into twice T2 minus T2. That is Cp into T2 will give you the answer. That is 1 into Cp into T2. Cp known hai. Our objective is to find out T2 now. 1 to 2 is isentropic. 1 to 2 is isentropic. So T2 by T1 is equal to V1 by V2 to the power gamma minus 1. And what is V1 by V2? That is 14 to the power 1.4 minus 1. So T2 will come out to be, T2 is equal to T1. What is the value of T1? 27. 273 plus 27. 300 into 14 to the power 0.4. यहां से T2 की वैल्यू केल्विन में आ जाएगी. Put the value of T2 here, you will get the answer. What is the value of T2 in Kelvin? What will be the value of T2 in Kelvin? 14 to the power 0.4 multiplied by 300. Isn't it? 862. 862.13 Kelvin. और ये अगर पुट कर देंगे तो Qs is equal to Cp. Options are in kilojoule. So Cp should also be taken in kilojoule per kg Kelvin. 1.005, 1.005 into 862.13. That will be your answer into 1.005. 866.4 kilojoule per kg will be the answer. 866.4 kilojoule. D will be the answer. बताइए, isn't it? So again we are running a ground zero series. क्या होता है इस ground zero series में? For those who are preparing for GATE 2025, we are discussing the important concepts from the basic to the advanced level. And the series is running on our Byjus exam prep app, and you can download it from the Google Play Store, or you can find the bit.ly link in my description of this video, so that you can install it and start attending the sessions through this series. And another important series we are running is for post-GATE guidance. Sessions are there again on our Byjus exam prep app only, where we discuss the cutoffs for various NITs, other PSUs and other institutes. So do not forget to be part of these sessions as well on the Byjus exam prep. Question number 6 on your screen. Question number 6. Consider a one-dimensional, it is a beautiful question. Consider a one-dimensional steady heat conduction process through a solid slab of thickness 0.1 meter. It is a solid slab having a thickness 0.1 meter, 0.1 meter. It is very, very important question. The higher temperature side A has a surface temperature of 80. TA is equal to 80 degrees Celsius. And the heat transfer rate per unit area Q dash is equal to the low temperature side is 4.5 kilowatt per meter square. The thermal conductivity of the slab is 15, K is equal to 15 watt per meter Kelvin. The rate of entropy generation per unit area during the heat transfer process is, because the heat transfer process is an irreversible process, so there is always an entropy generation. So first of all, apply the concept of conduction to find out the temperature at B. सबसे पहले TB find out करेंगे. How? Q dash is equal to K into TA minus TB by L. So from here, Q dash is equal to 4.5 is equal to or into thickness is equal to 0.1 is equal to K 15, TA is 80 minus TB. यहाँ से you can easily find out the value of TB. What is the value of TB? What will be the value of TB? TB will come out to be 50 degrees Celsius. कितना होगा? 50 डिग्री सेल्सियस. अब तो ये तो था हीट ट्रांसफर का कॉन्सेप्ट. अब ध्यान दीजिए जरा, प्लीज हैव एन अटेंशन, प्लीज हैव ए लुक. हियर द टेम्परेचर इज TA given, here the temperature is TB. There is the heat flow from A to B. So this is our system. Let us say for this system, can we write entropy equation? Can we write entropy conservation equation or entropy equation? We can say entropy transfer or change in entropy of the system, change in entropy of a system is equal to entropy transfer that is happening due to heat transfer plus entropy generation. Change in entropy. And if we write per unit time, so ds by dt for the system is equal to, how is the entropy transfer taking place? Along with the heat transfer, heat entering minus entropy leaving plus entropy generation per unit time. This is per unit time. So for a steady state system, it is in steady state. The system is in steady state, and for an steady state system, can we write this to be ds by dt will be equal to 0. So 0 is equal to s dot I minus s dot E plus s dot generation, or we can say s dot generation is equal to s dot E minus s dot I. Right? So what is entropy generation? We can say entropy leaving is due to heat transfer. So it will be Q dash by TB minus Q dash by TA. Yes or no? Q dash by TB, that is the entropy leaving, because heat is leaving, heat is entering, so entropy is entering. So Q dot is taken constant. Then we can say entropy generation can be written as क्या होगा? We can say entropy generation rate is equal to Q dot into TA minus TB upon TA into TB. Put the value 4.5. TA minus TB is equal to 80 minus 50. 80 minus 50. Sorry. 80 minus 50 upon 273 plus 80 into 273 plus 50. This will give you the answer. This is going to give you the answer. Your answer should be in watt per meter square Kelvin. So do not forget to take 4.5 into 1000. 4.5 into 10 to the power 3. That will give you watt per meter Kelvin. कर सकते हैं 273 plus 80 into 273 plus 50. And 80 minus 50, 30 divided by this answer, then multiplied by 4500. 1.184. 1.184 watt per meter square Kelvin will be the final answer. That is how we can solve for entropy generation in the system. So these were the questions from the, these were all the questions from the thermodynamics and its application. Now let us move to some questions from the fluid mechanics. The velocity field for a two-dimensional flow is given by this expression. Very good expression. It is related with ui cap plus vj cap. The total acceleration is, what is the total acceleration? Kyonki it is 2D flow, so the total acceleration is axi cap plus ayj cap, isn't it? That will be the total acceleration. Or the magnitude of total acceleration is under root of ax square plus ay square. So our objective is to find out ax and ay, ui cap plus vj cap. So from here u is equal to x by t and v is equal to minus y by t. What is ax? Ax is equal to del u by del t plus u into del u by del x plus v into del u by del y. U is not a function of y. U is not a function of y, but u is a function of temperature, time. So del u by del t is x into minus 1 upon t square. Yes or no? Plus u is x by t into del u by del x. Del u by del x is 1 by t. So minus x by t square plus x by t square is equal to 0. Ax will be 0. Similarly, you can find ay. Ay is equal to del v by del t plus u into del v by del x plus v into del v by del y. Because v is not a function of y, v is not a function of x, this will be 0. Del v by del t, that is minus y into minus 1 by t square plus v, that is minus y by t into del v by del y, that is minus y. So it will be ay will be equal to minus plus y by t square plus y by t, y square by t, sorry, del v by del y is minus 1 by t, sorry, minus 1 by t. So y by t square plus y by t square, so that is 2y by t square. Ay will be equal to 2y by t square, ax will be 0. So the magnitude of total acceleration is under root of ax square plus ay square. That is simply ay only. That will be ay only. So 2y by t square j cap is the final answer. ये पूछा था, ax is 0, so ay is 2y by t square and the final answer. The given velocity field is incompressible, rotational, irrotational, incompressible, etc. कैसे सॉल्व करेंगे? Again, that is equal to ui cap plus vj cap. U is equal to x by t and v will be equal to minus y by t. U for incompressible flow, what is the continuity equation? If we apply the continuity equation, that is equal to del u by del x plus del v by del y is equal to 0. So if we talk about LHS, what is LHS? Del u by del x 1 by t plus del v by del y, that is minus 1 by t, that is equal to 0, that is RHS. So the flow is incompressible. Yes, the flow is incompressible. Compressible is incorrect. Compressible is incorrect. A and C are possible. And for irrotational flow, omega about z axis, that is half of del v by del x minus del u by del y must be 0. So omega z can be written as half of, what is del v by del x? Del v by del x, v is not a function of x, 0 minus del u by del y, u is not a function of y, is equal to 0. So it is irrotational. The flow is incompressible as well as irrotational both. The flow is irrotational as well as incompressible both, right? Question number 9. Next one, question number 9. The loss of head in a pipe of 100-meter length carrying oil. The fluid is oil. Volume flow rate is 100 LPS. What is LPS? Discharge is 100 liter per second. Is estimated to be HL. The loss is HL. If the pipe of double the diameter becomes 2D. But of same length, D2 becomes 2D1. But of same length, L2 is equal to L1. Is to carry discharge of Q2 200 liter per second. Then what is the head loss? HL2. What will be HL2? So we can say HL is given by FLQ square upon 12.1 D to the power 5. Length is same, friction factor, nothing is given regarding the friction factor. 12.1 is constant. So we can say HL is proportional to Q square upon D to the power 5. So HL2 upon HL1 is equal to Q2 by Q1 whole square into D1 by D2 to the power 5. Can you solve it? HL2 Q2 by Q1, that is 204 HL into 4 into D1 by D2. D1 by D2 is equal to 1 by 2. So 1 by 2 to the power 5. 32. 1 by 32. So HL by 8 will be the correct answer. It will be HL by 8. Agla question. The ratio of turbulent boundary layer thickness to the thickness of laminar boundary layer varies as. What is the thickness of laminar boundary layer? It is proportional to x to the power 1 by 2. Yes or no? What is the thickness of turbulent boundary layer? It is proportional to x to the power 4 by 5. So delta T upon delta L is equal to x to the power 4 by 5 upon x to the power 1 by 2. That is x to the power 4 by 5 minus 1 by 2. How much is that? That is delta T by delta L is equal to x to the power 10, 8 minus 5. That is x to the power 3 by 10 will be the answer. D will be the correct answer. Question number 10. Question number 11. We need to find out the equation of the streamline. The flow field is given by this expression U I cap plus Vj cap. If you compare this, then U is equal to Ax, V is equal to minus Ay. What is the equation of the streamline? Differential equation of the streamline is dy by dx is equal to V by U. Put the value of V by U. Put the value of V. V is equal to minus Ay. What is U? U is equal to Ax, A getting cancelled out. So dy by y is equal to minus dx by x. Integrate it. So ln of y is equal to minus ln of x plus constant. Right? So ये हो जाएगा ln of y is equal to minus ln x plus ln of constant, isn't it? So ln of y is equal to ln of c by x, natural log getting cancelled out. Xy is equal to constant. Xy is equal to constant. And at 1 comma 1, at 1 comma 1, c is equal to 1. So our expression is x into y is equal to 1. This is the equation of the streamline. C will be the answer. C will be the correct answer. Question number 12. In a certain fluid flowing through a 200 mm diameter pipe, the diameter of the pipe is 200 mm. The shear stress at the boundary means the shear stress at the wall is 10 Pascal. The loss of head due to viscous friction in 0.1 kilometer, that is the length of the pipe, it is in given in kilometer, is. So HL is equal to delta PL by rho g. That is the loss of head. And how to calculate delta PL? Because tau naught is equal to minus dp by dx into r by 2. That is tau. Tau will be given by this expression. So tau naught is equal to delta PL by L into capital R by 2. From here we can write delta PL is equal to 2L tau naught by R. 2 into length is 100 meter into tau naught is 10 Pascal upon radius is 100 mm 0.1. So it will be delta PL is equal to 20,000 Pascal. In Pascal it will be 20,000. 20,000 Pascal, if you want to convert it into kilopascal, that will be 20 kilopascal. If we want to convert it into bar, 0.2 bar. Yes or no? So 20 Pascal is incorrect. 2 bar is incorrect. It is 0.2 bar. 200 Pascal is incorrect. So अगर इस वैल्यू को यहां पे पुट कर दें, HL is equal to 20,000 upon density of water. It is water क्या? In a certain fluid. Density तो given नहीं. So अगर इसको convert करें, if we convert this delta PL in terms of water, so in terms of water, how to convert it in terms of water? क्या करेंगे? In terms of water, so delta PL by rho G, rho of water into this. Delta PL 20,000 into 1000 into 10. So it is around 2 meter of water column. It will be 2 meter of water. B will be the correct answer. B will be the correct answer. Right? Question number 13. Question number 13 on the screen. The length of a laminar part of the boundary layer on a smooth flat plate is 25 centimeter. Smooth plate पे boundary layer कैसे grow करती है? Like this. Right? The length of the laminar part of the boundary layer. This is the laminar part. And the length, this is called as XCR, is equal to 25 centimeter. If the viscosity of the fluid is 0.1 stock, it is the kinematic viscosity stock, or 0.1 into 10 to the power 4 minus 4 meter square per second. Isn't it? What is the velocity of the free stream of the fluid? So we can say critical Reynolds number, that is 5 into 10 to the power 5, is equal to U infinity into X critical upon kinematic viscosity. U infinity will be equal to 5 into 10 to the power 5 into 0.1 into 10 to the power minus 4 upon X critical 25 into 10 to the power minus 2. That will be your answer in meter per second. That will be your answer in meter per second. Can you solve it? So it will be, how much is that? This will get cancelled out with this. So it will be 1 by 5 into 10 to the power 2. Or how much is that? 1 by 5 is 0.2 into 10 to the power 2 meter per second. Or it is 20 meter per second will be the correct answer. Option D will be the right answer. Option D will be the correct answer for this one. Next one, question number 14. A 1.8 1:8 reduced scale model of a reaction turbine. It means if the diameter of the model is equal to 1, then diameter of prototype will be 8. Is tested under a head of 15 meter. So the model head of model is equal to 15 meter and the power output for the model is 22 kilowatt. The prototype turbine has to work under a head of 100 meter. HP is equal to 100 meter at 180 RPM. What is the power rating of the large turbine? That is PP will be how much? So overall efficiency is equal to power upon rho q gh. Yes or no? So power is proportional to q into h. Power is proportional to d square into v into h. Or power is proportional to d square into v is root h into h. So our expression is power is proportional to d square into h to the power 3 by 2, 1 plus 1 by 2. Power is proportional to d square into h to the power 3 by 2. So pp by pm is equal to dp by dm square into hp by hm to the power 3 by 2. So power of the prototype is equal to, what is the power of the model? 22 kilowatt. 22 into dp by dm 8 square into hp by hm. hp is 100, hmb is 15. 100 by 15 to the power 1.5, that is in kilowatt. Can you do the calculation? 100 by 15 to the power 1.5 multiplied by 64 into 22, that will be kilowatt. So it will be 24236.27 kilowatt. If we want to write in megawatt, 24.236 megawatt will be the value of pp. 24.2 megawatt will be the correct answer. One more question for the day. The last one, question number 15. A cubic tank is filled with water to a depth of 2 meters. There is a cubical tank. This is 2 meters, this is 2 meters, and it is filled 2 meters. The fluid is water. The force acting on one side of the tank when it is accelerated at g by 2 meter per second square vertically upward. If the acceleration is g by 2 vertically upward, then what will be the force? G is equal to 10 meter per second. What will be the force on one side? Hydrostatic force. So F is equal to rho of water into G into A into X bar. G is the effective gravity because acceleration due to gravity is acting in downward direction. What is G effective? Isn't it G plus G by 2? Isn't it 3G by 2? So if you put the value of G effective, density of water 10 to the power 3, G effective is 3 by 2 into 10 into area is 2 into 2 into X bar is 1. That will be Newton. If you want to write in kilonewton, then 60 kilonewton will be the final answer. 60 kilonewton will be the answer. Alright, so that is all from my side for this test. So tomorrow I am going to have a session at 5:30 p.m. on the Byjus app for GATE 2025 aspirants, where I will be discussing about the concept of heat generation in the plane wall. Very, very important and beautiful concept, important concept from your examination point of view. How the heat generation is analyzed in case of a plane wall. So do not forget to join me tomorrow at 5:30. Till then, enjoy, take care. And we are also running paid courses for 2025 aspirants and 2026 aspirants. If you are interested to be part of our paid courses, then give a call to the counselor. The number is already mentioned, or you can just fill the counseling form. Our counselor will have a one-to-one discussion with you for the same. All right. And if you are not part of my Telegram channel yet, it is my humble request, please do join me on the Telegram, and you will definitely get a lot of benefits for your efficient and effective preparation. With this note, let me take your leave. See you tomorrow at 5:30 on the Byjus app. Till then, have a good night and Jai Hind.